This is lesson 7.5C, the third video, intermediate algebra, dealing with a review of systems of linear equations in two variables. And we are on example number 6. So let's go ahead and write that as 1/2 x minus 1/3 y, and that is equal to 2. And we have 1/4 x plus 2/3 y equals 6. Okay, so the biggest headache we have there is the fractions. So let's go ahead and get rid of the fractions. You could do it without getting rid of the fractions, but it's kind of a pain in the neck. So let's go ahead and get rid of the fractions by multiplying the entire thing first of all by the common denominator, and this time, or the common multiple, and this time it's 6. So we get, let's see if I can write this next to it in real small. Alright, we get 6 times 1/2 x minus 6 times 1/3 y equals 6 times 2. And that gives us 3x minus 2y equals 12. So we rewrote that without fractions. Let's do the same thing here. We're going to multiply the whole thing. Common multiple is going to be 12. So let's multiply everything by 12. Alright, and that gives us 3x plus 8y equals 72. Alright, so there and there are our new equations. So let's go ahead and write them down here. That's the top one. Doesn't matter which order you put them in, whether you put them, you know, this one I'm writing right now on top or on bottom. Doesn't really matter. Okay, now notice what I have here. I have a system of equations, and notice my x's are the same. The only difference is one's a negative and they're both positive. So we can take this equation and change all the signs, or this equation and change all the signs, so that we get a -3 on one of the equations. It doesn't matter. So let's change all the signs to the top one. And leave the bottom alone. Now we add, those go away. We get 10y equals 60, and y then equals 6. Okay, so now we take this answer here and plug it in one of these equations. Again, it doesn't matter which one. Let's just take the top one. Sorry, I'm not talking much here. So my answer then is 8 and 6. Those are my two answers. 8 is my x and 6 is my y. So the only difference we did there is we had a fraction. We got rid of the fractions first. Then we did the system of equations by making these the same number in front of the x, only opposite signs, so that when we added them we got 0. Okay, let's jump to the substitution method, and that is example 7. Okay, number 7. This is using the substitution method. Now the one we did before was the elimination method. You can solve systems of equations using the substitution method or the elimination method. It does not matter. You will still get the right answer if you do everything correctly. It's just sometimes the elimination method offers an easier way than the substitution, and vice versa. Sometimes the substitution is an easier method than the elimination. In this particular problem, the substitution method is going to be the easier of the two, simply because we know what one of the variables equals. And when that's the case, when we have one variable by itself on one side of the equal sign, we know we're going to use substitution, because all we have to do is, in this top equation, whenever we see a y, we're going to plug in 3x minus 5. So we're going to put a 3x minus 5 there, which means we only have one variable in this. We have an x there and we'll have an x there. So let's go ahead and write that as 2x minus 3, and instead of a y, we're going to group in parentheses 3x minus 5 equals negative 6. We're going to use distributive, add the x's, subtract 15, divide by negative 7, and my x is going to equal 3. Alright, so my x is 3. Now I need to find out what my y is. So I take and put this 3 into either one of those equations up here. Doesn't matter, but the easiest one is going to be that one. Now the thing is, it's nice, is you're not going to be wrong by putting it in for the other one. It just is going to be a little bit more difficult to solve the problem. So, when my x is 3, my y is 4. Alright, and that works. Now you'll notice in example 8, we have 2x plus 3y equals 5. And then we have an x minus 2y equals 6. Alright, so you could use elimination or substitution for this, but the instructions say solve by using substitution. So whenever it says solve by substitution, you take one of the equations, it doesn't matter which one, and set it equal to a variable. So how do you know which one? Well, you look for the easiest equation, and one of the easiest ways of seeing which one's the easiest is which one, if any, have just a variable with no number in front of it. If you get one like this with an x with no number in front of it, that's the one you want to use. So what we're going to do is we're going to add 2y to both sides, and we get x equals 6 plus 2y, or 2y plus 6. So now I've got that equation. I look at my top problem, and I put in 6 plus 2y in there for x. Plus 3y equals 5. Okay? So now I'm just dealing with this one equation. I'm not dealing with both of them. So 12 plus 4y. So that gives me 12 plus 7y equals 5. Subtract 12, and I got 7y equals negative 7. So y equals negative 1 for that one right there. Now I go back and I take my y equals negative 1 and I plug it in to any of the equations, doesn't matter, but that's the easiest one since it's already set up to find x. And I do x equals 6 plus 2 times negative 1. So x equals 6 minus 2, or x equals 4. So my answer then is 4, negative 1. So remember, when you put your answers down like that, make sure you remember to put them in the right order, x and y there. And that's it for those. Now let's go ahead and look at a couple of the applications. And the first application is example 9. It takes 2 hours for a boat to travel 28 miles downstream. So we have a boat going downstream, and it takes 2 hours, and the distance is 28 miles. Alright, the same boat is going to travel, instead of 28 miles downstream, it's going to travel 18 miles upstream. And it takes 3 hours because it's going against the current. What is the speed of the boat in still water? So that means if there is no current, what would be the speed? So let's make a little table. Let's make an up and a down. Alright, so our distance, and let's see if we can get rid of some of this here. Our distance upstream is, what did we say? Our distance upstream is 18 miles. Our distance downstream is 28 miles. And how fast are we going? We have no clue. How much time is it going to take? Well, I know it's going to take 3 hours to go upstream and 2 hours to go downstream. Okay, so my difficulty is finding something to put in here for the rate. Alright, so the rate is going to be, well, let's make x be the speed in still water. Okay, because that's what we're looking for, right? What is the speed in still water? So if it goes x mile an hour in still water and it's going upstream, it's going to slow down. When it goes downstream, it's going to go faster. So let's make x the speed in still water, and let's make y the speed, because again we're missing the r, so that's what r is speed. The speed of current. Okay, so when it's going upstream, it's going a certain speed minus the current because it's fighting the current. So it's going to go x in still water minus however fast the current is pushing it backwards. Okay, so when we're going upstream, you've got a current pushing it this way, y. So we have x going upstream, y pushing against it, so the difference, the rate, is going to be the speed the boat's trying to go minus the speed of the current. Now when it's going downstream, it's going to be going the speed in still water plus the current is going to help it. So the speed of the current is going to help, so it's x plus y. Alright, so that gives me this nice little table here that I can start messing around with. Okay, so if you remember, the formula for distance with rate and time is d equals rt. Alright, so let's go ahead and move this up a little bit. Alright, we'll move that up there, and we'll move that up there. Okay, so that's what we want. So we're going to use this formula, distance equals rt. So the going upstream, it's 18, distance equals rt. Let's put the t first. Okay, so that's the speed, or that's the formula going upstream. Downstream is 28 equals, alright, so now we have two different equations there. Let's go ahead and do the distributive. Oops. Alright, let's get this right. And 28 equals 2x plus 2y. I'm just going to take this and flip it completely around and make it 3x minus 3y equals 18, just because I like having the variables on the left. So notice nothing has changed there. I just flipped it around just so it's easier to work with. Alright, let's see if we can get all this stuff out of here that we don't need anymore. And this is all we really need. Okay, so if that's the case, I'm just going to rewrite it over here so that I minus 3y. Okay, I'm just trying to get it away from everything else. Alright, so that's what I'm trying to solve. Now notice in this one here, I can pull out a 3. And in the bottom one, I can pull out a 2. Okay, so basically what I'm doing is kind of like reducing a fraction. I'm just pulling out those numbers, and I pull them out and I reduce it to look like that. Okay, I don't have to pull them out. I could leave it this way right here, but this just makes it easier. Alright, so the next video will continue with that one.